Hi everyone. Let's see, we're going to go over notes 4.1a today. I don't necessarily know why there's an A there, but there won't be any more than just 4.1a for our unit 4. This one is pretty hefty. This is the last chapter of the entire unit, and there's about 7, maybe 8 days of this material. And it is very, very, very important. All right. As we go through this, you'll learn more about what's called the unit circle and what have you. Everything that we do from this point on is what you will take into second semester of Trig, as well as calculus if you head into calculus as well. Okay, so as we start Unit 4, you have officially made it to trigonometry, and we will get started. So for 4.1a, it's called measuring angles. All right, so we're not going to start off too terrible in 4.1. All right. However, we have two things that we need to pay attention to. When we do an angle, we have two types of sides. One side is going to be the initial side. All right. And when we do the initial side, it will always be along the x-axis. So initial, think the word like start, it's your starting side, and it will always be with your x-axis. And we will practice that today. And then we have what's called your terminal side, as I overlap that very poorly. Okay, your terminal side is going to be the side that your angle is opening up towards. All right, and of course your angle here, that is a Greek letter, and that Greek letter is called a theta. So as we move forward, whenever we're talking about angles, we're going to be talking about thetas. And really, it's just a circle with a dash through it. That's what a theta is. All right. Don't need to worry about the oval shape, just a circle with a dash through it. And then, of course, we have what's called the vertex. The vertex you guys have seen in Algebra 2. You've also seen it in Algebra 1. And then we will see it here again as well. So vertex is just where the two sides are going to come together at that single point in the middle. And we have our vertex. All right, so terminal side, initial side, and vertex. And then going on, we have an angle is in standard position. All right, so if I asked you for the standard position of an angle, these are going to be the rules we are going to follow. So for one, its vertex is at the origin of a rectangular coordinate system. So if I had my grid, if I had my xy axis here, standard position is if the vertex lies in the origin. And then its initial side lies along the positive x-axis. So remember how we talked about the initial side just a second ago? That's the same thing. I'm talking about that side, and it's going to lie along the x-axis. So right now it's in standard position, and then I need my terminal side. Let's just throw that in quadrant 2 here. This is just an example. My terminal side is going to go off into quadrant 2, and then my angle is measuring everything up until that point there. Okay, so that angle is the entire thing. You have that full 90 degrees plus a little bit more over to the left, that second quadrant there. Okay, so we'll get some practice on what all this means and how it applies to all of Unit 4 and go from there. So when I give you angles, there's going to be two ways we can measure these angles, or two ways we have to identify these angles. Okay. For starters, if I had a positive angle, then you are going to go counterclockwise. All right. Now, if you think of angles and you think of your XY axis right now, before this whole graph got started and your initial side and everything, I'm going to go in with green. If I took this theta and I did a full circle, you would tell me that the angle of that circle would be 360 degrees. All right, and that's true. You did a full circle, so it's 360 degrees. Same thing is going to be applied. Every single time you hit an axis, you have gone 90 degrees. The next axis, you've gone another 90 degrees. The next axis, another 90. And then, of course, the fourth axis, you've gone a total of 360 degrees. All right. So if you take a look at these, you will see that the left-hand side talks about positive angles. So whenever I have a positive angle, I get to open counterclockwise. So this would be a full 360 degrees, and then I can even keep going another 360 degrees and keep going that way. Those are all positive angles. But if I gave you something that was a negative angle, let's say like negative, I don't know what, like 85 degrees, because it's negative this time, we now have to go clockwise. So you always start at this initial side, but since we had a negative angle, it's going to stop right before my 90 degrees. And of course, our angle is getting measured by theta, and in our case, it would be negative 85 degrees. Okay, so 2 takeaways from here. When I give you a positive angle, you're going to go counterclockwise, just like a normal circle. You're going to go around the circle. And then if I gave you a negative angle, you're going to go clockwise. You got to work backwards. All right. And just some refreshers here. If we talk about quadrants, this is always quadrant 1, and then you keep going. Quadrant 2, we use Roman numerals when we talk about quadrants. Quadrant 3 is in the bottom left corner, and then quadrant 4, which gets labeled as IV. All right. Another thing about our quadrants, the first quadrant is going to be everything from 0 to 90 degrees. Second quadrant will be everything from 90 degrees to 100 degrees. And you're just adding 90 degrees each time. So then you have 180 to 270. And then last but not least, 270 to 360. So each quadrant is going to have those values. Now, if I went negative angles, however, it's going to work backwards. So really, this quadrant's going to be 0 to negative 90 degrees, and then negative 90 degrees to negative 80 degrees, and so forth. Negative 180 degrees to negative 270 degrees, and then negative 270 degrees to negative 360 degrees. So it's the same thing, you're just working backwards. Okay, so let's get into some examples, just practicing and then graphing. So for example, 1 through 4, it asks us to draw each angle in standard position. So if we think again what standard position means, we have to have our initial side on the x-axis. And then we also need to state what quadrant it lies in. So for questions 1 through 4, I'm going to draw an xy coordinate here. Just knock them all out at the same time. It's just a sketch. I don't need anything perfect. All right. And then when I have 153 degrees, well, I know it's definitely greater than 90, so it's got to go past. Okay, first of all, actually, let's backtrack. 153 degrees is positive, so I have to first graph that counterclockwise. Okay, you have your vertex right in the origin. Initial side is on your x-axis, and then it's going to open up. You know it's opening past 90 degrees here, but it's not going all the way to 180 degrees. It's actually going to stop a little ways in. Okay, again, I don't need a precise graph. I'm just focused on an angle drawn in standard position and what quadrant it's going to lie in. So if I know that it's not going to go past 180 degrees, I know that it will look something like this, and you can label your theta if you want and say that it's 153 degrees. And then just double check, where does that angle lie? Well, you're all the way open into the second quadrant, so my answer to that would be quadrant 2. Okay, now if you want to use regular numbers and not Roman numerals, that's totally fine as well, but that is what I'm going to use as a reference. All right. For question 2, this time we have a negative angle, so we have to work backwards. So instead of going counterclockwise, we need to go clockwise. So the same rules apply. You have your vertex at the origin. Your initial side is on your x-axis, but this time when I open, it's going to open down. And it's a little bit past 90 degrees, So I get to pass that y-axis there, and it's going to open up here. And again, if I label my theta, I have negative 95 degrees. Now, just because it was negative doesn't mean it's going to change the quadrant that it ended up lying in. I'm still going to say that it's still in quadrant 3 at the end of the day. Okay, all that the negative angle is telling me to do is just to open up the other direction, the clockwise direction, as opposed to the counterclockwise. So I'll go ahead and try question 3 here. 225, vertex in the middle, initial side. You're going to open up to 90, 180, and then the next one would be 270, but that's too big, so it's going to finish in the third quadrant. So your angle isn't all of this here. Your angle is actually all of this here. It's an open, pretty wide angle. And that makes sense because our angle is representing a positive 225 degrees. And this is in quadrant 3 again. Okay. And last but not least, question 4. So if I anticipated any sort of mistakes on these, it's probably going to be with the negative angles. All right. I get tripped up sometimes as well. So we just have to keep remembering that, one, if you see a negative angle and you're asked to draw it, it's going to go backwards. So we have to go clockwise at the origin, initial side, and then just count to yourself. Every single time you hit an axis, it's another 90 degrees. So we have negative 90, negative 180, negative 270, and then a little bit more because we're not going to 360. So this is going to open almost to a complete circle, but not fully. And your angle is negative 250 degrees, and this opens in quadrant 1. All right, so that's just angles. From here on out, we're going to talk about two things. We're going to talk about angles measured in degrees as well as radians. All right, radians is something you probably most likely have never seen. Again, this is a trig concept. So this is what we're going to use. We're going to use radians and degrees from here on out. Okay, more importantly, radians, if that's probably going to be the more common way we discuss our questions from here on out. And this is just an intro to radians. We'll start to understand radians a little bit more as we go through in the notes for Unit 4. But we'll just have a quick starter here. So, the relationship between degrees and radians. So if I had this XY axis in front of me with that circle, all right, I'm just going to draw a random angle. Just like you just did, I'm going to have my initial side, my vertex, and then let's just go ahead and open up into the first quadrant here. All right, and we'll label some things. So your initial side was here, if I can spell that correctly. All right, followed by your terminal. And then that vertex is that point, combining both sides. All right. On the inside is your theta. Your theta tells you your degrees. All right. And then the radians, so the degrees is the angle measure, and the radians is actually going to be this arc right here from one side to the other. You're measuring that arc of the circle. And so we will say the intercepted arc is always radians, and it is always going to be in terms of pi. Okay, and that, my friend, is our radians. So the only difference between radians and degrees is measuring the angle, whereas radians is going to measure the arc. Okay, if you think back in geometry, you talked about that, radians, degrees. You didn't talk about radians, but you did talk about arc length, and you did talk about angles and what have you. So all we're changing now is instead of saying arc length, we're talking about radians. And the same rules apply. If I went counterclockwise, that means that my radian value had to be positive. My arc is going to be positive. But if I went clockwise, then my radian value would be negative. It's the same exact thing as your degrees. If your degrees were negative, you're going to draw your angle clockwise. And if your degrees were positive, you would draw your angle counterclockwise. All right. So before we get into some examples here, we have to know how to convert one from the other. All right. And it's really, really, really simple if you just think about it. All right. If I go back to this picture up above, notice these two functions here. And this will make so much more sense as soon as we have that unit circle mastered. All right. We're not there yet. So it's going to be kind of something that you just have to accept at the moment. And then we will conquer it in a couple sections from now. All right, so if you notice these two formulas, they both have 180. So let's tackle that first. If I looked at this graph, I know that 180 degrees is from my initial side here all the way up and to the left over to this side. So a flat line is going to be 180 degrees. And as a quick reference to what's coming ahead, 180 degrees is the exact same thing as pi radians. Once you've gone 180 degrees, it's the exact same thing as pi radians. So it's going to be basically a function of 1. So pi radians divided by 180 is the same exact thing over each other. We just have to learn how we're going to convert one from the other. But it doesn't matter as long as we know that pi and 180 degrees go hand in hand. All right. Again, we will master that as we go through chapter 4's notes. But if you can keep that in mind, it will help you today. So go ahead and take a look at these functions. All right. And then take a look at these examples. So the first function says to convert degrees to radians. You're going to multiply by pi radians divided by 180 degrees. Well, think about what that's saying for a second. If I had 75 degrees and I wanted to convert that into radians, what's going to have to cancel on the top with my 75 degrees that I also need to cancel down below? You're going to need your degrees to cancel with each other. So that, if you can't remember the formula, that's a good way to remember. If you have degrees to start with, then you're going to have degrees in the denominator so that they will cancel each other out. And I will show that in example 1 here down below. So if I have 30 degrees, I have to convert from degrees to radians. So I want to essentially get rid of my degrees. Well, the only way to get rid of degrees when 30 is up in the numerator is to put 180 degrees down in the denominator so that your degrees can cancel with one another. And then if we remember, 180 degrees pairs well with pi, and we call that pi radians. And then we just go ahead and simplify. Well, 30 and 180 can cancel into 1 and 6. And then if we multiply, we have 1 pi over 6. And together that's 1 pi radians over 6. Okay, so I understand it's going to be weird. We're introducing pi today, but it's going to be so much easier when we get into the nitty-gritty details of chapter 4 and all of trig. All right, so all we're doing is converting. Keep it simple. Don't try to overthink. So I have negative 135 degrees. Again, I want to cancel my degrees, so I have to put the other version down in the denominator, and then pi goes up top. And if you want to write radians, you can, okay? From here on out, if I see a pi, we're going to know that it's in radians as it is because it's always what radians is in terms of, just like we wrote up above, all right? And then if we simplify, we get negative 135. Oops, no longer degrees, right? Because that's what we were trying to cancel. Pi over 180. We can, of course, simplify that. They have a 5 in common. They probably have a lot more in common. It looks like they have a 9 in common, potentially. Yeah, we can practice that. You can type it in the calculator. Ignore the pi portion. You're just focused on the values, negative 135 over 180. So if you type that in the calculator, it will give you a decimal. And then if you hit the math button and hit enter, you will get your answer as a fraction. And so it will convert this for you into a negative 3 over 4. That's all the calculator will do for you. And then just make sure that you keep the pi with it as well, because you are only doing the values in the calculator. Don't find the pi button on the calculator. You'll get a decimal and it won't convert to a nice fraction later. So we always want it in terms of pi. Do not apply the pi. Sounds kind of funny. Do not apply the pi. All right. Go ahead and try question 3. We have 272 degrees times pi over 180. I'm going to simplify this time while I'm doing my work. And you'll have 68 pi divided by 45. So again, make sure your answer is always in terms of pi if you want it to be in radians. Okay, no decimals, nothing like that, because then you won't be able to tell the difference if it's in degrees or if it's in radians. All right. Now we're going to do the same thing, but we're going to do it reversed. So now we're given radians and we're asked to put it in degrees. So again, if you forget the function, here's an easy way to remember. For question 1, you have pi over 3. Well, you're going from radians with pi into degrees. So you have to get rid of the pi and introduce your degrees. Well, if you have pi up here in the numerator, the only way to get rid of pi is to put it now in the denominator so that they can cancel with one another. And then in order to keep it the same sort of function, we want to put it with 180 degrees up above. If I do the math, my pi's cancel. 180 divided by 3 is going to give me 60. And this time, of course, I converted it into degrees. So I will have 60 degrees. Continue with question 2. You have negative 7 pi over 12. You're looking to cancel the pi again, so that needs to go in the denominator. And 180 goes in the numerator. Your pi's cancel. Let's see, 12 goes into 180. I believe it goes in nicely. Yep, 15 times. So I can reduce that to a 15 or reduce that to a 1. And now I can distribute and multiply, and you will get a negative, oops, not 85, excuse me. You'll get a negative 105. And of course, you converted it to degrees, so make sure you include that degrees symbol. Go ahead and try question 3. Check back on the video if you want to check your answer. You're just converting. Pi's cancel. 4 can go into 180. 45 times. And then 5 times 45 will give you 225. And remember, you converted it to degrees, so make sure you label it as such. So just practicing converting. Okay. And then for the last page, we're going to talk about coterminal angles. And it's exactly what you think it's talking about. When I say the word co, the prefix, it's meaning two. All right, and then if you read the definition, it's going to make some sense. So it's two angles with the same initial side, but possibly different rotations. All right, so I'll give you an example of what that means. If I have an angle with my vertex in the origin, initial side here, let's say that angle is 80 degrees. So it's going to still stay in the first quadrant. Okay, so that's my first angle. But a coterminal angle is saying it's two angles with the same initial side, but possibly different rotations. And what that means is if I have the first angle, such as 80 degrees, let's make a second angle, and I will do that here in a highlighter so you can tell the difference easily. Same initial side, but this time I'm going to do a rotation, a full circle around here, and then I'm going to also go to 80 degrees. So I'm going to overlap that in red here for you. Same initial side. I'm going to go 90, 180, 270, 360, plus 80 more. And when I do that additional 80, I'm still going to have that same coterminal side, but this time, instead of 80 degrees, I'm going to have the full circle, the full 360 first, plus the additional 80 degrees. So for this angle here, I would have 440 degrees. So a coterminal angle with 80 could be 440 degrees. If I add another 360 to that, it could be 800 and so forth. So if you keep adding rotations, otherwise known as like circles, if you keep adding 360 degrees, you will still have the same angle, just at a different rotation. That's what that vocab means, right? So let's try another example, but this time let's do negatives. So I'm going to have my vertex, my initial side, but this time I'm going to talk about a negative angle. So let's use the example, actually before I do negatives, let's do this. I'm going to show you a coterminal angle that could be negative. So if I had an initial side, and I'm still going to open it up positively because I'm going to have an angle that's this time 240 degrees. So it's going to be in the third quadrant. All right, I'm just giving you examples. If I asked you for a coterminal angle that paired up with this, you could add 360 and keep it positive. That's totally fine. But you could actually do it the other way as well. All right. And what that means is I can go with the same initial side, but instead of going the positive direction, the counterclockwise direction, I can go the negative direction here. And it's going to share the same terminal side. Now, because I'm choosing to go clockwise, I know that my angle is going to be negative. And in fact, if I took 360, because I know altogether this is going to make 360 with between my 240 plus my new angle, I know that in order to make a full circle, I am missing a total of 120 degrees to get me to that 360. But because I'm going backwards, because I'm going that clockwise direction, I know that this is going to be negative 120. So if I had an angle that was 240 degrees, and I asked you for a coterminal angle that is negative, you could tell me that negative 120 will count as a solution. And that works, okay? You're just adding circles to it or subtracting circles to it. It's the same value, either adding 360 degrees or subtracting 360 degrees. And you can keep it going. It doesn't just have to be 360. It could be 360 and then another 360 and another 360. As many rotations as you want, and it will still count. All right? So we're going to do the last set of examples here. And it says find a positive angle, so I need positives for my answer, that is less than 360 degrees, that is coterminal with each of the following. Okay, that should probably have a period with it. And then always add or subtract in increments of 360. All right, and that's what we've been talking about this whole time. Those are called full rotations. All right, so a rotation is the same as a full circle, full 360 degrees. And so there's some hints here to get you started. So if you have a positive degree, you're going to find the full rotation under, which means you're probably going to have to subtract a rotation. Subtract 360 degrees. And similarly, if I gave you a negative degree, you're going to have to add a full rotation over. All right? And then if you're still not between these two things here that they asked us for, we just got to keep repeating the process. All right? So the end goal is we want a positive angle that is less than 360. So in other words, we want an angle that is between 0 and 360. If I want it to be positive, it's got to be greater than 0, but also less than 360. So if I look at example 1, I have 420 degrees, all right? First of all, 420 degrees is above 360, so in order to get me in between 0 and 360, I have to subtract. So I'm going to subtract 360 degrees. You can use your calculator. I don't need to see the handwritten work. And when you do that, you will have a positive 60 degrees. Now, is that between 0 and 360? Yes, it is. So that can be my coterminal angle. At 420 degrees, if you subtract a rotation, if you go backwards a rotation, the coterminal angle with that will be 60 degrees. It's still the same angle, just at a different rotation. All right. Go ahead and look at question 2. This time we have negative 120. We want it to be between 0 and 360, so it has to be positive. Well, the only way to take a negative value and make it positive is to potentially add a rotation. So we'll start with one rotation, and if we need more, we'll just keep repeating the process. So if I have negative 120 and I add 360, your coterminal angle will be 240 degrees. It's between 0 and 360, so we are good to go and submit this answer. Now for question 3, however, I have 1,380 degrees. That's quite a big angle. So it's way over that 360 that my limit is, but I'm still going to repeat the process. I'm still going to subtract 360, see where that takes me. It gets me to 1,020 degrees. Well, that's still way over. So guess what? I have to repeat and subtract another 360. That's going to get me to 660. Still over. Going to subtract 360 again. And that gets me 300 degrees. Well, 300 degrees is indeed okay. It is between 0 and 360, so I can stop there and submit my answer. All right. And if you think about coterminal angles, I know these examples have the restrictions between 0 and 360, but if you think about it, if you started with 1380, another coterminal angle with it could be 1,020. Another coterminal angle could be 660. And another coterminal angle could be 300. All of those are considered coterminal angles, but because the directions asked for a positive angle less than 360, I had to keep going to get my final answer between 0 and 360 degrees. All right, but they are all considered coterminal angles. Question 4, this time I have a negative 500 as my angle. So So I want to add 360 this time. It's going to still give me a negative value, which is negative 140. That still doesn't follow my restrictions, so I need to add another 360. And that gives me a positive 220. Follows my rules. It is between 0 and 360, so I can combine them. And it is still coterminal. The other coterminal angle I could have potentially used was negative 140, but again, because of the restrictions, I couldn't use that value. All right. And now for questions 5 through 8. All right, we did the first 4, and they were in terms of degrees. So for questions 5 through 8, you can do one of two things. All right. We know how to convert radians to degrees. So if you like using their degrees and solving and moving things around, by all means, convert it to degrees. And then when you have your final degree value, that's between 0 and 360, you can convert it back into radians as your final answer. Okay? If worst comes to worst, you can totally do that. But I'm going to do it a different way. All right? If you look back up at this example here, with this graph, okay, I told you at 180 degrees, we have gone a total of pi radians. So what if I asked you if we go a full 360 degrees? So here's 180, so that's 1 pi. Then what if I doubled it? What if I did another 180? That's going to be 2 pi. You just doubled your pi. You just doubled your 180. So you went from 180 to 360. So you did the same thing with your pi. You went from pi to 2 pi. You doubled it. Okay? That is considered a full rotation. You just completed a full circle. 2 pi is that full circle. So when I do questions 5, 6, 7, and 8, when I add rotations or when I subtract rotations, because these next few problems are in terms of pi, I'm going to either add my rotation of 2 pi to both sides, or to my original, or I'm going to subtract a rotation of 2 pi. So the only difference for questions 5 through 8 is because it's in radians, but I either add 2 pi this time or I subtract 2 pi. And all we know about that is it's a full 360 degrees, but this time it has to be in terms of radians. All right, so I'm just going to rewrite it here so I can get some room. I have negative 5 pi over 4. Well, first of all, it's a negative, so I can't have a negative as an answer. So I have to add, and I'm adding a rotation of 2 pi. All right. Well, I have a fraction plus 2 pi, so if I think of my rules with fractions, let's make that 2 pi over 1. I need to have a common denominator. So if I look at 4 and I look at 1, their common denominator will be a 4. And by changing the 1 into a 4, I multiplied by 4, which will now change this 2 into an 8, and the pi will still remain. Okay, now they have the like denominators, so I can continue. Negative 5 pi plus 8 pi, I can combine these because they are both in terms of pi, so they're like terms. That's going to give me a 3 pi with the same denominator of 4. All right, and if you think of your answers for the first set, we wanted our answers to be between 0 degrees to 360 degrees. For radians, we want the same thing. It's going to go from 0 radians, but instead of 360 degrees, it's going to go into 2 pi. Okay, so my max is 2 pi. If I have the answer 3 pi over 4, ignore the pi for just a second and check out 3 over 4. Well, 3 over 4 is the same as 0.75. 0.75 is still between 0 and 2, so I know that I am in the clear and I am good to go. Let's try question 6. 13 pi over 5. 13 pi over 5, well, if you think about that, if you took your denominator and plugged that in and you actually divided 13 by 5, you know that 5 can go into 13 more than 2 times, a little bit more than 2 times. All right, so the fact that that can go in more than 2 times, you know that you can completely take out a full rotation. Because it can go in 2 times, you can take those 2 times out by subtracting your full rotation. Same thing, get the same denominator, and then we can subtract. 13 pi minus 10 pi is going to give me a 3 pi over 5. Again, 3 over 5 is still less than 2, so we are good to circle our answer. Continuing on, negative pi over 4. It's negative, so that automatically tells us we want to add 2 pi this time. Get the same denominator. This time it's a negative 1 pi plus 8 pi, so that's going to give me a 7 pi over 4. Okay, that one's pretty close, but if you check 7 divided by 4, you actually have 1.75, which really isn't too quite yet, so you know you are still within the restricted zone. So we can finalize our answer. That looks kind of bad. Let me rewrite that there for you guys so you don't get confused. And that's pi. Okay. Question 8. If you want to try it on your own, by all means, go ahead and do so. Again, this is negative, so we automatically want to add 2 pi. Get the same denominator. Change the numerator, and then we can solve. So we get a negative 5 pi over 6. That is still negative. We don't want negatives, so we're going to add another 2 pi. Get the same denominator. And this time when you add, you're going to get a positive 7 pi over 6. That is, in fact, between 0 and 2 pi, so we can say that is our final answer. All right. So as you go over these notes, don't worry about the pi. The pi will make a lot more sense as we go through Unit 4. All right. The biggest thing I need you to remember is what's called radians. Radians introduce pi. They are always in terms of pi, and they go hand in hand with degrees. All right, and so as we go through what's called the unit circle in this unit, you will get to see the similarities between degrees as well as pi, as radians. All right, the other takeaway is coterminal angles. Okay, you can have more than one of the same angle. It's just going to be on a different rotation. All right, same angle, it's just a different rotation. It's still going to measure the same from your initial side. It just has a full circle added to it or a full circle subtracted to it. Or maybe even multiple circles added or subtracted to it. That's another takeaway. And then last but not least, please remember these two functions. In order to convert, they go hand in hand. They're just flip-flopped, all right? And if you get stuck on which one's the numerator, which one's the denominator, we're just thinking what has to be canceled. And if it has to be canceled, then that needs to be in the denominator when you go to multiply so that you can be left with radians if you need radians, or you can be left with degrees if you need degrees. Okay. That is all the takeaways, and of course, if we talk about, if we talk about positive angles, you are moving counterclockwise, and if we talk about negative angles, you are going to move clockwise, so forwards as opposed to backwards.